My research is mainly based on creating new materials that could improve upon mobile communications and wireless communications. I'm currently working on materials that could improve the way that we communicate wirelessly over long ranges. This could include mobile phone signals and among other commercial and industrial applications. My research is important for many different reasons, not only from a commercial point of view. There are millions all over the world that have mobile phones. From an industrial point of view, everything from communications all the way out to aerospace, everyone needs to be able to communicate. If we can do that more effectively with less power and less energy, that would be beneficial to everyone.
My project is looking at how we can apply well-known concepts in metamaterials, whether it's electromagnetic or acoustics, and applying it to fluid flow problems. My research is important because everything in the modern world works in a fluid, whether it's a plane or a boat or something like that, it's in a fluid and it always experiences drag, which is the resistance to the motion of a body through a fluid. If we can use some concepts in metamaterials to reduce this drag, you have massive savings in energy and various other things.
The CDT is the Centre for Doctoral Training, funded by the Engineering and Physical Sciences Research Council, which is you, the taxpayer. And we have £5 million from the government to train PhD students in the area of metamaterials. So the idea is that you provide for society, and we will provide for society about 14 trained PhD students every year for the next 5 years, funded by government. And they will go out and be entrepreneurs or researchers, develop new technologies to keep the UK ahead of the rest of the world in this space. So we're the only CDT in metamaterials in the country, and we're probably the biggest CDT, single institution CDT in the country in that space.
I work with a company that does a lot of maritime investigation, and we're looking at how we can reduce maritime noise, in particular ultrasound. So this is frequencies which we use for scanning babies, for looking at it for very particular cases of applications for this sound. And what we use is something called a pressure release material. And this hasn't been investigated at all really underwater. We are at the forefront of this sort of research. Not many acoustics departments have the equipment that we do. So it's interesting, as in I feel like a professional when I'm doing my work, because not many people know about it and it hasn't been investigated.
My experience working at the University of Exeter has always been really good. It's a very nice, positive, collaborative area. As part of the XM2 CDT, there's approximately 40 PhD students at the moment, all working on different metamaterials projects. So we've got quite a strong collaborative atmosphere. If multiple people were stuck on a problem, we can all come together and solve it. As well, it means with the supervisors we have dual supervision. We can work, we've got a big team behind us working on different things. We also have quite a strong focus working on industry, so as part of the training in the CDT we go to various different industries and learn about how they work and have quite close ties with them.